Hi everyone. Today we're going to talk about vector operations. So we're going to learn how to add, subtract, and multiply two vectors. The first thing that we will learn is vector addition. To add two vectors, you need to place the head of one vector at the tail of the other one and draw a new vector from the tail of the first vector to the head of the second. So what does this mean? Let's say we have two vectors a and b and we want to find a plus b. So I'm going to take one of them, the b, and put the head of that on tail of the other one. The initial point of a vector is called the head and the terminal point is called the tail. So I'm going to put the head of b on tail of a. So it's going to be like this. The head will be on tail of a. So this is vector b. And then a plus b is going to be the line that connects the head of a to the tail of b. So this line that connects head of a to tail of b is called a plus b. So that's how we add two vectors. Now let's see how we can subtract two vectors. Before learning how to subtract a vector, we're going to learn about opposite vector. The opposite of a vector is a vector which has the same magnitude but points in opposite direction. It's written as negative v. For example, if this is vector v, opposite v is going to be a vector the same magnitude but opposite direction. So that's called negative v. Now to subtract two vectors like a and b, we need to add a and the opposite of b. For example, a minus b is a plus negative b. So how do we do that? Let's say we have a and b here. So we're going to take b and find the opposite of that. So the same magnitude but a different direction. So we take this negative b and add it to b. And we learned that to add one vector to other one, we need to put the head of the second on the tail of the other one, like this. So as you see, this is negative b. And the result vector is a line that connects the head of A to the tail of B. So this one is A minus B, like what we have seen here. If we wanted to add A and B, we would just take the A and put it on the tail of A. Take the B and put it on the tail of A. And this line would be A plus B. But if I want to subtract them, I take A and opposite of B and put it here. This will be, the other one will be A minus B. Okay, now we're going to work on these examples. We have vector u as 2 and negative 1 and vector v as 4 and 2. And we want to find 2v plus 3u. So first of all, let's learn how we add just the two vectors u and v. We're going to learn how to do in geometrically and both algebraically. So first of all, let's do u plus v geometrically. Vector u is 2 and negative 1. That means I need to go 2 to the right and 1 to the bottom. This will be vector v. Oh, I'm sorry, this is vector u. So vector u is 2 and negative 1. Then I'm going to add v to this vector. So I need to go 4 to the right and 2 to the up. But I'm going to do that from the end of u because we know that we need to put the v at the end of u. So we're going to start from this point and go 4 to the right, 1, 2, 3, 4 to the right, and 2 to the up, 1 and 2 here. So this one is v. Now if I just connect the head of u to the tail of v, this line is u plus v. So this is how we add u and v together. But how do I do that algebraically? Vector u plus v will be a1 plus a2 and b1 plus b2. So a and b are the x and y components of u and v. Like this is a1, b1, this one is a2, b2. So we just need to add the x components together and the y components together and then write them down. So u plus v will be 2 plus 4, which is 6, and negative 1 plus 2, which is 1. This is u plus v. Now let's work on 2v plus 3u. So first of all, I'm going to find 2v. 2v is 2 times vector v. Just simply multiply the 2 by both the x and y components. So it will be 8 and 4. And 3u is 3 times u, which is 2 and negative 1. So it will be 6 and negative 3. Now 2v plus 3u will be just simply the x components of 2v plus x components of 3u, which is 8 plus 6 and 4 and negative 3, 4 minus 3, which will be 14 and 1. So this is how we algebraically add them together. Now, if I want to graphically or geometrically find 2v plus 3u, I'm going to start from here. I will start graphing 2v, which is 8 and 4. So that means I need to go 8 to the right. Let's say this is 8 and 4 up. So we went 8 right and 4 up to graph this vector, which is 2v. Then we have 3u. That means I need to go 6 to the right and 3 down because it is 6 and negative 3. So 3u will be 6 to the right. Let's say this is 6 and 3 down. Something like this will be negative 3. So this will be the graph of 3u. Now the result function of 2v plus 3u will be this line that connects the head of 2v to tail of 3u. So this line will be 2v plus 3u. Okay, now let's find v minus u. Okay, so we know that v was 4 and 2, and also we know u is 2 and negative 1. Now v minus u will be just simply subtracting the components like 4 minus 2 and 2 minus negative 1, which is 4 minus 2 is 2, 2 minus negative 1 is 3. So this is v minus u. Now how do I graph that? Let's start. First of all, I'm going to graph v, which is 4 and 2. So I go 4 to the right, 1, 2, 3, 4 to the right, and 2 up. This is v. Now I want to find v minus u. So first of all, we need to find negative u. If you remember, we said we need to find the opposite v first. It will be negative 2 and positive 1. Just multiply a negative by these components. So the next step is to graph negative u starting from the end of v. So I need to go 2 to the left because it's negative. So 2 to the left here and 1 up here. This is negative u. Now the result function is a line that connects the start of v to the end of negative u. This line is v minus u. Okay, so this was about adding and subtracting vectors. Now let's talk about multiplying them. Vectors dot product is when you multiply two vectors. Dot product of two vectors has a formula like a1 times a2 plus b1 times b2. Basically, just multiply the x components and add it to a multiple of the y components. The dot product is always a real number, a scalar, and it's not a vector because it doesn't have any direction. It's just simply equal to a number. Okay, so here I have u and v, and I want to find u times v. A1 and B1 are here. B1 is 1 because there is no coefficient here. That's actually 1. And for V, we have A1, A2, and B2. So A2 is 5, B2 is negative 6. Notice that we have a negative here. Now U times V is A1 times A2. That means 2 times 5 plus V1 times B2, which is 1 times negative 6. So it's 10 plus negative 6, which is 4. So as you see, the dot product of two vectors is just a number. It's not a vector. It doesn't have any direction. It's just a scalar. Now, what are perpendicular vectors? Two vectors are orthogonal or perpendicular if their dot product is 0. This is actually dot product. It's missing a C here. So if their dot product is 0 or u times v is 0, they are perpendicular. Let's try these two vectors. I'm going to find u times v for these two vectors. U times v is a1 times a2. That means 3 times 4 plus 2 times negative 6. 2 times negative 6. So it will be 12, and this is negative 12, which is equal to 0. That means these two vectors are perpendicular. Means the vector, the angle between these two vectors is 90 degrees. Okay, so now what are parallel vectors? Two vectors are parallel if they are scalar multiples of one another. What does that mean? Let's say, for example, we have vector u here, and the x and y components are 2 and 3. On the other hand, we have vector v, which has components of 4 and 6. If you notice, the components of v are 2 times the components of u. That means v is 2 times u. This is called a scalar multiple of another vector. So if one vector is scalar multiple of the other one, then we say these two vectors are parallel. For example, let's say this is u, this one is going to be v. They both have the same direction, so they are parallel, just the magnitude of them are different. One of them may be bigger or smaller than the other one. Now let's see how we can find the angle between two vectors. Means if we have two vectors like u and v, and we're interested to find the angle between these two, let's call that theta. How do we find this theta? Dot product of two vectors has basically two different formulas. One of them is this one that we see here. We use this when we have the x and y components like a and b. And the other one is this one. This one is used when we have the magnitude of, and the angle between the vectors. So we take the magnitude of one and multiply by the magnitude of the other one. This is supposed to be v. And multiply them by the cosine of the angle between them. Now, if I want to find this angle, I can use this formula. So I need to get cosine of theta by itself first, and then I can find theta. To get the cosine of theta by itself, I can get rid of these two magnitudes. So I'm going to divide both sides by magnitude of v times magnitude of u times magnitude of v. So these two cancel each other. And from here, we know that cosine of theta is going to be u times v. U times v over magnitude of u times magnitude of v. So this is how I can find cosine of theta. And after that, if I take the inverse function of cosine of whatever we have here in this fraction, that will give us the theta, or the angle between two vectors. So let's practice this example. We are interested to find the angle between these two vectors. So we're going to use this formula. uv over magnitude of u times magnitude of v. uv is the dot product between these two vectors, and we can find it using this given formula over here. So I'm going to multiply x component by x component, which is 4 times 2, plus x component of this one times, y component of this one times y of the other one, negative 3 times 5. So it will be 4 times 2 is 8, 3 times 5 is negative 15, 8 minus 15, which is negative 7. So that's the top of this fraction. Now for the bottom, we need to find magnitude of u and magnitude of v. Magnitude of u, if you remember, we can find it using this formula, a squared plus b squared under radical. So it will be 4 squared plus negative 3 squared. 16 plus 9, which is 25, it's equal to 5. And then magnitude of v will be square root of 2 squared plus 5 squared. So that will be 4 plus 25, and it's radical 29. So here we can write 5 times radical 29. 5 radical 29. So cosine of theta is equal to negative 7 over 5 times radical 29. Now from here, theta will be cosine negative 1 of negative 7 over 5 radical 29. And I can use my calculator to find that. Cosine negative 1 of negative 7 over 5 times radical 29 is 105 point something. So we can round it as just 105 degrees. So the angle between two vectors is 105 degrees. And this was today's lesson. Have a good day.